Hey friends, welcome back to the channel, and in this video let's talk about one of the dangerous trend that is taking over the tech industry, and people call it vibe coding. So in this, what you generally do is open an AI powered code editor that can be anyone like Cursor or Codex, which is whichever you like, and then you write in plain English whatever you want, and then the AI or the LLMs just write down hundreds of lines of code in a matter of seconds or minutes in front of you, and you don't read the functions, you don't check the memory allocation, you don't know the data flow or the code flow, how things are working, and you just hit run. And if it runs, then well and good, you're in good shape, you got whatever you wanted, and you just did a bug, or you made a feature in just a few minutes, and you simply ship it, and you're just riding the vibe. But in the short term, well, it's really good. You feel like a superpower, you feel like a 10x developer just because you built an app over the weekend. But the brutal truth is that vibe coding is an engineering death trap. Well, relying entirely on LLMs or AI without understanding what's happening, and it is making you operate out of a black box. And the main negative of that is when that black box collapses. For example, the code that you ship in the production, and something wrong happens with that, you don't have any idea about how that black box used to work, and what are the technical details, and where are the things that you need to fix at that particular time. Okay, so in today's video, I'll share my opinions, what I think of where this vibe coding is leading engineers, and what I do to not to brain rot in this kind of vibe coding trend, and to not to hit the career dead end, and why I think that most of the developers who want to make it big in the future should master low level debugging, system architecture, and these are the things that you should have a mastery on to be a good engineer in the future, and to separate out yourself from these vibe coders. So first, let's understand what is the scope of AI in the job of a software engineer. Well, I feel that AI tools are incredible tools, and I think these are the tools that every engineer should use, because they save you a lot of time. Like, they have automated boilerplate, they generate test suite, and they draft initial syntax, and you need not to understand all the programming languages. Like you can understand different languages in plain English by just asking how things are working. But one thing to note is that problem is not AI. It is the problem is that the people are shifting their mentality from engineering to kind of guessing. So whenever we used to write code by hand, we used to understand how the code is working, like what is the flow of the code, what is the higher level design that people have implemented, or you are going to implement, what are the edge cases. You'll know edge cases in detail because you actually spent a ton of time thinking about those edge cases. You know how the memory is allocated, how what are the trade-offs that you have done. For example, like why you have used in-memory cache versus database query. So you understand how all these problems work, how the architecture is driven. Well, but on the other side, when you are vibe coding, you skip this entire mental model. You accept the code what the AI has given to you, and most of the time you don't go through it fully, and you just hit run, and if it is working fine, then you are going over to the next step. But it's good for a simple to do apps, but if you're talking about the software engineering in the real world, it is not just about generating code. It's more about managing complexity over time, taking business decisions, and have a comprehensive understanding of the trade-offs that you're doing, of the tech stack that you currently have, and the design that you want to achieve. Well, and the other thing that I want to highlight is the AI retry loop, uh, or why the people are struggling that much because of vibe coding is because the low level debugging is kind of dead. So generally what I've seen is what people do, let's say they found a bug or something in their code, they would just type in like just for example, just take example of a UI, and let's say there's a button that is not visible. So most of the time what people do is simply take a screenshot, get it over to their code editor and just write, okay, so this button is not visible with this workflow like that. And you don't have any idea about the code, and then the AI model will do something. They will just uh, like generate hundreds of lines of code, and you'll see, you'll now run again and you'll see that it's still not working. What you will do again, you'll write another prompt to the AI like the issue is not fixed till now, and you just give another prompt with the another screenshot. And this is the kind of a real trap, and this is like the AI is stuck in an infinite prompt retry loop. And 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 because of this, the code is getting longer, messier, and harder to read, and that is basically a code rot. But on the other hand, what I feel as a good engineer, what we should do is we should not try to prompt the AI to guess what's the actual issue is. What we should do is we should find out the root cause by ourselves. We should understand the logs. We should understand how the threads are working. What is the root cause by having like trace of memory usage, by having logs at the correct the correct location, by understanding how the design is working, what was the idea behind these design implementations. And when you understand that low level execution, you can debug fast and you can solve these problems quickly, rather than just being dependent on an AI to fix all of these issues. Now let's talk about what I think is the future is going to be of software engineers. So because AI is quite recent, and before AI, people used to do all these kind of things. Whenever they used to hit a blocker, they used to surf through the internet. I think Stack Overflow was one of the best website at that time, and it was kind of a research that people used to do. So let's say they hit a like any issue regarding to memory allocation. If you talk about C++, that is kind of a crucial part, and you'll see people going on different forums, different websites, understanding how things are working, understanding how the OS works, understanding how the different syntax of C++ language in general. But now it's more of uh, uh, like a question and answer game, where you can simply go to cursor or any AI editor. You can prompt out what are the things that you need, and you'll just simply get an answer. So you are not researching you're not researching quite a lot. And but now, as the AI is increasing, there are I think not software engineers but syntax operators that are on rise. Well, these are the developers whose primary skill is gluing APIs together and writing basic CRUD operations using AI prompts. And because the barrier to entry in this particular field is falling to zero, the supply is skyrocketing. Like people with a basic BTech degree can do these kind of CRUD apps with a prompt, and the market value of this skill is collapsing. And if your main value proposition is I can write code fast using AI, you are just competing with millions of entry level candidates doing the exact same thing. While on the other hand, if we talk about experienced professionals, or people who are giving as much attention to system design, to system engineering, or the architecture of the code that they are developing, they are understanding how the low level execution is happening. They understand how the memory management is working. They know about concurrency, distributed systems, and they are the ones who know when the AI is hallucinating over a subtle memory leak, or like a silly mistake. They know how these microservices architecture are breaking, and they know what is the root cause, and they're using AI to just speed things up, not to replace their thinking process. And I feel that in the future, maybe a few years down the line, companies will be paying top salaries to these kind of people who understand, have the understanding of architecture, and not to those people who are simply pasting the AI code. And now the question is how to get future proof in your engineering career if you are still new in your career. So that is what I feel, and what I'm trying to do in my job is I think the main skill of a software engineer is to master the fundamental debugging. So we need to like stop relying on print statements or the prompt loops with the AI, but we should learn how the actual debuggers work. We should understand the memory profilers, network sniffers, and the performance tracing tools, so that whenever we hit a bug or anything, we know how we can trace the execution at the system level. And the other thing is to understand that AI is a multiplier and not a replacement of anything. So I feel these AI generators should be handled with care. Like we can understand, we should treat these AI generators more of an intern, where let's say I need help in a particular operation, and I can just prompt it to my intern, like I know this particular thing to be done, and when the AI is done with that execution, we should understand line by line what this is done. And I think if I cannot explain the code generated by AI line by line to someone in my team, this is the code that I have not written, and this is the code I not push to anywhere unless I have understood it. And the other thing that I wanted to highlight is to understand the higher level ideas behind architecture or system design or the business logic or the trade-offs that people do. So what I've seen is AI is great for small tasks or some uh, or some small bugs, but if we have a broad context, AI model struggles a lot, and they kind of hallucinate and make tons of incorrect incorrect assumptions, and they give a lot of wrong results. So what I feel is the ability to translate complex business requirements into resilient, maintainable software architecture is where the true value lies. And for this, we need to have the understanding of the architecture, system design, the trade-offs, and the in-depth knowledge of the different kind of techs that are available in the market, and in a broader term and in depth as well, so that we can take intelligent decisions, and we don't rely on AI for like everything. So in the end, I would just say that vibe coding is good, AI tools are good, but these are more of a multiplier that you can use in day-to-day life to enhance your performance, to look up things that you don't know, or to do some kind of repetitive tasks that you are doing in your work. But I think you should not consider them as a black box, and you should be going through all these codes line by line and understand how things are working on the higher level, and to have a fair idea about the low level execution and low level debugging. So this is these are what are my opinions on vibe coding, and how this is a kind of threat to like software engineers, especially the ones who are entering their software engineering career recently. So that's it for today's video. See you in the next one.